Welcome to the deep dive. This is where we take a whole stack of sources, dig through them, and pull out the really important insights and nuggets of knowledge for you. Hopefully you leave feeling well-informed, maybe a bit surprised.
Yeah, hopefully.
So today we're diving into something that gets dismissed a lot by mainstream science, but it just keeps sticking around, sparking debate, especially now in 2025 among, let's say, alternative researchers. We're talking about the flat Earth theory.
Hmm.
Our goal here, our mission for this deep dive, is to really unpack the arguments. What are the proponents actually saying? We'll look at their observational evidence, how they read historical texts, and their skepticism of the official story, the institutional narratives that, challenge that standard spherical model.
Okay.
Okay, let's unpack this. Here's where it gets really interesting.
What's fascinating here is how this whole perspective really pushes us to question what we just accept as truth. It kind of encourages critical thinking about even these super widely accepted facts, even stuff that seems totally self-evident. It highlights that tension between, like, intuition and the scientific models.
Absolutely. And when you start digging into the actual arguments flat earthers make, one big theme jumps out pretty quickly.
Yeah.
They really lean on direct sensory observation. What you can see and feel yourself rather than abstract theories or models.
Really trust your senses.
Yeah. They argue that what we actually experience lines up better with a flat plane. And one of the points they bring up constantly is the horizon. It looks flat, doesn't it? And they say whether you're at sea level or even like way up high in a balloon at 100,000 feet, that line just looks straight, not curved.
Yeah, it's interesting, isn't it? You see all this footage now from drones, high-altitude balloons.
Yeah.
It gets shared a lot on platforms like X, especially this year,
Yeah.
2025. And yeah, it often really does show what looks like a flat horizon.
Yeah.
So for flat earthers, that's direct evidence. It contradicts the curve you'd expect on a globe, one that's supposed to be around 40,075 kilometers round. It just taps right into that basic trust in what your eyes are telling you.
Makes sense. So it's like rejecting the complex physics for the simple visual proof. Okay, but what about water? I mean, that's fundamental. How does water fit onto a flat plane versus a curved one?
Well, that's another huge pillar of their argument. Flat Earth proponents insist that water always finds a level surface. It just naturally stays flat, right?
Okay.
Think about a big lake or the ocean. They argue it looks flat across huge distances. And the whole idea of water somehow sticking to the outside of a curved spinning ball, well, they say that just defies common sense.
Especially with the spin.
Especially with the spin. They bring up the centrifugal force, the Earth supposedly spinning at 1,000 miles per hour at the equator. They think that should be throwing water off, or at least making it bulge noticeably. There was that X post going around recently, something like, water doesn't curve, find me a lake that bends,
Yeah, I saw that. It's a powerful sort of common sense point for people. And haven't they done experiments too to try and show this?
Exactly. They often point to things like the Bedford Level experiment. There was a revival of it back in 2017, I think.
Right.
And the claim was that over a distance of like 6 miles, they couldn't detect any curvature in the water's surface. So for the proponents, this just reinforces their whole view. Water sits flat on a flat plane.
Even if mainstream science interprets those results differently?
Right, even if there are other explanations like refraction. For them, it's about that direct observation, and it really makes their common sense case feel strong. And this leads right into another big point for them, the fact that we don't feel the Earth moving.
Yeah, that comes up a lot. If we're spinning at 1,000 miles an hour and zooming around the sun at 67,000 miles an hour, why don't we feel it? Why isn't the wind constantly howling or something?
Precisely. That's the question they pose.
Yeah.
And phenomena that science uses to show rotation, like stars appearing to move in fixed patterns, or those long exposure photos where you see star trails making circles.
Yeah.
Well, they interpret that completely differently. They see it as evidence not of a spinning Earth, but of a rotating firmament, like a dome above a stationary Earth.
Yeah.
The fixed patterns are key for them.
So the stars are moving, not us. Okay.
Yeah.
So if direct observation is so central now, how do they weave history into this? It seems like flat Earth advocates often point back to historical records to, back up their claims.
Oh, they absolutely do. And what's interesting there is how they highlight that actually a lot of ancient civilizations, Egyptians, Babylonians, early Hebrews, they described the Earth as, well, a flat plane, often under some kind of dome, a firmament.
Are there specific texts they cite?
Yeah, often they might point to biblical texts like Genesis 1.68, describing that firmament separating waters above and below. Some flat Earth folks interpret that quite literally as evidence of a solid dome over a flat Earth. And they'll also mention that Islamic and Hindu cosmologies apparently contain references to flat Earth models too. Like the Quran Surah 88.20 describes the Earth as spread out. So it's this whole narrative that reframes history, suggesting the flat view was the original common understanding.
So it's not just a modern fringe idea. They argue it has ancient roots. And what about the shift away from that towards the globe model? They seem to suggest that wasn't purely scientific, right?
That's another key part of their argument, yeah. They contend that the shift, starting with figures like Copernicus, Galileo, back in the 16th century, that it was maybe driven less by solid proof and more by philosophical shifts or even political agendas.
Really? Political agendas?
Well, that's the claim. You see things like a 2025 pamphlet from the Flat Earth Society alleging that modern space agencies like NASA, they perpetuate the globe model basically to keep control over the scientific narrative and funding. It's a pretty strong critique of scientific authority.
Wow. Okay. And do they use old maps to support this idea?
They do. They often highlight specific historical maps. A famous example is the 1892 Gleason's azimuthal equidistant map.
What does that show?
It depicts the Earth as flat, basically a disk, centered on the North Pole. And Antarctica isn't a continent at the bottom. It's like this massive ice wall circling the entire edge of the plane.
An ice wall.
Yeah. And proponents argue that this kind of map actually aligns better with how early explorers navigated, suggesting maybe that was the real understanding of the world back then, before the globe model took over.
Okay, so if we connect all this back to the bigger picture, the flat Earth theory isn't just offering different observations. It's actively challenging some core scientific ideas that prop up the spherical Earth model.
Precisely. Like take the Coriolis effect. The thing that supposedly makes storms spin certain ways and affects long-range ballistics because the Earth is rotating.
Right.
Flat Earthers often argue that its effects are actually really negligible or inconsistent. They question if it's even real. There was that X post I mentioned asking, if the Earth spins in 1,000-mile apart, why don't planes land way off target? It directly challenges a key proof for a spinning globe.
Okay. And gravity. That's pretty fundamental to the globe model, holding everything together, pulling towards the center.
They offer a totally different explanation. No gravity force pulling to a core. Instead, they proposed it's all about density and buoyancy.
Density.
Yeah. Objects fall, they say, simply because they're denser, heavier than the medium they're in, like air or water. Things find their natural level based on relative density. It completely removes the need for a mysterious force like gravity pulling everything towards the center of a sphere.
That's a radically different way of looking at it. And they're also pretty critical of NASA and the images we see from space, aren't they?
Very critical, yeah. Advocates often point to what they see as inconsistencies in satellite photos. Maybe continent sizes look different in various pictures, or cloud patterns seem duplicated, suggesting, digital manipulation, CGI.
Like the photos aren't real.
Or at least heavily edited composites.
Yeah.
There was that whistleblower claim circulating on X back in 2023, alleging NASA's famous blue marble photos weren't actual single snapshots, but rather stitched together composites. And this fuels their demand for, raw, unedited, publicly accessible footage from high altitude showing the curve. They argue that the lack of this kind of readily available proof is suspicious.
So it really comes back to transparency or perceived lack of it for them.
Very much so. And that ties into how they view the Antarctic Treaty of 1959.
How does that fit in?
Well, they see Antarctica as this huge ice wall surrounding the flat Earth disk, right?
The edge of the world, basically.
Kind of, yeah. And they argue the Antarctic Treaty, which heavily restricts independent travel and exploration there, is basically a way to prevent anyone from reaching the edge and verifying what's really there, or what isn't there, like a South Pole crossing. So you see lots of calls on X these days for open exploration of Antarctica. They think the treaty is hiding something.
Okay, let's unpack this a bit more then. We've heard their observations, their critiques, but how does their model actually work day to day? How do they explain things like day and night or seasons or even tides on a flat plane?
Right, so the basic model, as we touched on, is a circular flat plane. North Pole is the center. Antarctica is this ice wall boundary around the edge.
Got it. And the sun and moon.
They're not giant celestial bodies millions of miles away. In the flat Earth model, the sun and moon are much smaller and much closer. They're thought to orbit above the flat disk.
Orbiting above.
Yeah, moving in a kind of circular or spiral pattern over the surface. And it's this movement that creates day and night cycles. As the sun moves, it illuminates different parts of the disk.
Like a spotlight moving around.
Exactly like a spotlight. And the yearly path of the sun may be moving in a wider or tighter circle That's what they say causes the seasons.
And the
They're
stars.
set within that firmament, that dome structure over the Earth, which rotates, explaining why the stars appear to move in fixed patterns across the sky.
Okay, so how close do they think the sun is then if it's acting like a spotlight?
The numbers vary a bit, but a common figure you hear is around 3,000 miles above the Earth. Much, much closer than the 93 million miles in the standard model.
Wow.
Yeah. And they try to back this up. There was a 2025 YouTube experiment by a flat Earth researcher, Globebuster, I think. They used high-powered lasers trying to track the sun's path and claimed the results showed it appearing closer and smaller than the official estimates.
Interesting. Okay, what about tides? Normally we're told that's the moon's gravity pulling the oceans.
Right. Well, in the flat Earth view, since gravity isn't the main force they focus on, they propose other mechanisms, maybe electromagnetic forces or atmospheric pressure changes, something causing the water to slosh, essentially. It's definitely not lunar gravity in their model.
Okay, so they have alternative explanations. This raises an important question, though. If their model is the correct one, how do they handle the things that are usually presented as definitive proof of the globe? Like, what about lunar eclipses? Or GPS? How does that work without satellites?
Yeah, those are definitely challenges they have to address. For lunar eclipses, when the Earth's shadow supposedly falls on the moon, they propose alternative explanations. Maybe it's some other unseen celestial body that passes in front of the moon, or perhaps some kind of atmospheric phenomenon blocking the light. It's definitely not the shadow of a spherical Earth in their view.
Okay, and GPS.
Yeah.
We all use it in our phones, our cars. It relies on satellites orbiting the globe, right?
Well, they argue it doesn't necessarily have to. They attribute GPS functionality primarily to ground-based systems. Think extensive networks of cell towers, maybe supplemented by high-altitude balloons or
Like
drones.
pseudosatellites.
Kind of. And they often bring up older systems, like LORAN, that was a long-range radio navigation system the military used before GPS became common. They cite declassified documents about LORAN as evidence that you can achieve very accurate positioning using only ground-based transmitters and receivers. So they argue the whole satellite story might just be a cover for these terrestrial systems.
It's important, I think, to also acknowledge the social side of this. People who are skeptical of the globe model, they often face a lot of pushback, right? Ridicule, being dismissed as promoting pseudoscience.
Oh, absolutely. There's significant social and often academic ostracism. And that's actually something proponents use in their narrative. They draw parallels, saying, look, science has always resisted big shifts in thinking. They often bring up Galileo being persecuted for challenging the Earth-centric model back in his day.
So they see themselves as challenging an entrenched dogma.
Exactly. And that's why they push for open debate, for independent experiments that anyone can replicate. It's why events like the Flat Earth International Conference are important for them. The 2024 one apparently had like 2,000 attendees. It's about building community and legitimacy outside the mainstream.
Okay, this brings us to something really interesting. Stepping back from the purely scientific debate for a moment, what does the fact that this theory persists and in some ways seems to be growing tell us about our society right now, here in 2025?
It tells us quite a lot, actually. It's undeniable that the Flat Earth movement thrives online. You've got these huge communities on X, creators on TikTok getting millions of views. These digital spaces allow the ideas to spread rapidly and find receptive audiences, often in echo chambers.
And that online growth, it seems connected to something bigger happening culturally, doesn't it? A sort of distrust.
It really does seem to resonate with a wider, growing distrust in institutions generally, not just scientific institutions, but government, media, you name it. This distrust seems fueled by things like maybe perceived inconsistencies in how major events like the COVID-19 pandemic were handled, or general concerns about government transparency.
Is there any data on how many people actually lean this way?
Well, it's hard to get precise numbers, but you see things like online polls. There's one on X just this year, 2025. Apparently out of 10,000 respondents, something like 12% said they lean flat Earth. Now, it's just an informal poll, but 12% is, well, it's not insignificant. It suggests the idea has more traction than many might assume.
And does it connect with other cultural viewpoints, like religion?
Yes, definitely. It intersects with certain cultural and religious debates. Some religious groups, for instance, find the flat Earth model aligns better with a literal interpretation of their scriptures, their cosmologies, than the standard scientific model does.
So it taps into various existing beliefs and anxieties?
Exactly. And what's really fascinating here, I think, is how this whole movement kind of challenges the scientific establishment. It forces them, or perhaps should force them, to think about how they engage with public skepticism more transparently. It really highlights this broader cultural divide we seem to have between, institutional authority on one side and individual inquiry, sometimes bordering on conspiracism on the other. It's a tension playing out everywhere, not just about the shape of the planet.
So what does this all mean then, wrapping this up? Whether you personally land on the Earth being flat or a globe, I think this deep dive really shows the power of asking questions. And it highlights this persistent demand for direct proof, for experiments you can see or do yourself, and for real transparency from institutions.
Absolutely.
Yeah.
If we connect this to the bigger picture, the whole flat Earth thing, it isn't just about geometry or physics, is it? It's really about this deeper desire many people feel to reclaim a sense of personal investigation, of figuring things out for themselves. In a world that feels saturated with competing narratives and expert opinions, it embodies that ongoing tension between, established knowledge and that individual drive to question and verify.
Okay, so here's a final thought for you, the listener, to mull over. How does our own trust, or maybe our distrust in established institutions, how does that fundamentally shape how we perceive reality itself? And on the flip side, what responsibility do those institutions actually have to actively foster and maintain that trust in the first place? Something to think about.